Welcome to the Design for Excellence video tutorial from Experts for Excellence. In this video, you will learn what DFX stands for, why it plays an important role and how it is applied in practice. The video lasts about 15 minutes. You can pause it at any time to deepen your understanding of the content or to make your own notes. Please also note the disclaimer at the end of the video. And now enjoy Design for Excellence. First of all, what aspects should a development engineer or designer think about during their work? This question quickly leads us to the concept of Design for X, where the X stands for various factors, but also for the term excellence. One example is DFM, Design for Manufacturing. This involves considering how a product can be manufactured and assembled optimally, simply and cost-effectively as early as the product development stage. DFSC, Design for Supply Chain, refers to the selection of suitable raw materials, components or modules, taking into account their global availability and prices. This aspect is of central importance as it significantly influences the commercial success of a product. DFQ, Design for Quality, is about making development decisions in such a way as to ensure high product quality and a long service life. DFR, Design for Reuse, Refurbishment and Recycling, encompasses the entire reverse supply chain. The goal is to design the product so that it can be easily and efficiently recycled, refurbished or reused at the end of its useful life. These 7 X aspects are among the most commonly applied, but the list of possible development goals is endless. However, it is important to note that not all development goals can be pursued simultaneously. Often, you have to focus on the crucial aspect for the respective product. In some cases, 2 goals can be combined, while others hinder each other. For example, a high-quality standard can make it more difficult to achieve cost efficiency. Why is DFX important? To answer this question, let's look back a few decades. In the 1980s, the areas of development and design, manufacturing and procurement and transport logistics were often organized in isolation from one another, as independent silos with little communication or professional exchange between them. This often led to difficulties in production implementing what had been designed and constructed in development. As a result, production frequently had questions for development, which significantly delayed the time to market for new products. Furthermore, there was a lack of binding rules for the exchange between these areas. To address these challenges, the so-called concurrent engineering was introduced in the 1980s. In this approach, development and manufacturing engineers meet in the early stages of development to jointly evaluate the manufacturability of new products and to incorporate valuable manufacturing inputs into the development process. This approach quickly achieved visible success and significantly reduced the time to product launch. As companies became more aware of the advantages of concurrent engineering, they shared their experiences and institutionalized this approach in their own structures. At the same time, best practices from the industry were adopted. This is how what we now call Design for Excellence gradually came into being. Especially in the mid-1990s, when the outsourced manufacturing business model became increasingly important, it became essential to establish consistent rules for collaboration and information sharing across company boundaries. Today, electronic manufacturing services providers are demanding early involvement in new projects by their OEM customers, virtually, via a structured DFX approach. Example, Design for Manufacturing, DFM. The illustration on the right shows 2 versions of a simple bicycle bell. The left-hand illustration shows the design without DFM measures, while the right-hand illustration shows the design that takes DFM into account. At first glance, it is apparent that the design with DFM has significantly fewer components than the variant without. In addition, the DFM bell is much easier to assemble and does not require any tools, unlike the design without DFM. These optimizations lead to a more cost-effective manufacturing process overall, as well as to faster and less complicated assembly of the bell. How does the DFX process work? Let's look at the technology lifecycle using the so-called product lifecycle curve or S-curve. This curve illustrates that a product goes through various development phases in the course of its lifetime, from the development phase to the product launch and market maturity. In the early phases, especially during the so-called change window, it is possible to obtain valuable feedback from manufacturing after creating a prototype or while preparing for volume production. This feedback makes it possible to make constructive adjustments before the market launch in order to optimize manufacturability. It is of central importance to incorporate this continuous feedback into the so-called design rules. These guidelines provide developers with a clear framework to help them optimize future products in terms of their manufacturability. If feedback from production is consistently integrated into development, human resources in both areas can be reduced in the medium term. This makes it possible to schedule development projects more precisely and to implement them with fewer resources overall. This leads to shorter development times and thus automatically to a faster time to market. Getting your new product on the market earlier also gives you the chance to gain larger market share faster. Another key aspect is how DFX, specifically in the form of design for reverse supply chain, supports the circular economy. Let's look at a simplified product life cycle. It begins with the procurement of the raw material, continues through manufacturing and delivery, and ends with the regular use of the product. At the end of its useful life, the question arises as to what should be done with the product. If the reverse supply chain approach is taken into account during the development phase, the various elements such as reuse, repair, refurbish, service, remanufacturing and recycling can be implemented much more easily. Imagine what the reverse supply chain processes for a smartphone or laptop would look like compared to a battery for an e-mobility vehicle. What differences do you think there would? To fully exploit the benefits of a DFX approach, DFX must be institutionalized within the company. It is not enough to simply pass on the traditional production feedback to the development department. A structured approach is needed to ensure that all information, for example, about manufacturing capabilities, existing technologies or established processes, is systematically fed back to the development department and anchored in the design rules. This is the only way to ensure that the insights gained from production are fully taken into account when designing the next product generation. It is essential that DFX feedback be provided as early as possible. Feedback that is not provided until the volume phase of a product is often only incorporated as a product change in an emergency, for example, in the event of recalls in the automotive industry or in the food sector. Such recalls are not only extremely costly, but also significantly damage the brand image. It is more advantageous to collect feedback at a very early stage, during development or at the latest before volume production, and to incorporate it into the design. This is the only way to ensure that an improved product version is realized before the market launch. It is important that all feedback, whether from production or from the field, is collected in a structured way and recorded in the central design rules register. This ensures that the next generation or version of the product is free of defects and that valuable insights from previous production and use can be effectively implemented. We will now provide you with 3 examples of DFX. Example 1, Bathroom Cabinet. We compare a bathroom cabinet from a company named Held with one from the IKEA range. The focus is not on the design, but on the construction. Both models are assembled by the customer. The first thing you notice about the Held cupboard is that the list of tools required includes an electric drill, a device that not every household has as standard. By contrast, the assembly instructions for the IKEA cupboard are limited to tools such as a hammer, screwdriver and a small spirit level. Here, clear attention has been paid to design for assembly. Another aspect is the number of individual parts. While the Held cabinet consists of 29 different components, IKEA has used only 19 different parts through consistent standardization. Further proof of a well thought out design for assembly. Example 2, Automotive Industry. An example from the automotive industry, Volkswagen has developed a modular transverse toolkit, MQB, with a sophisticated system of design for assembly. This enables essential vehicle components such as chassis, engines, drivetrains and transmissions to be identical across models and brands. Only the superstructures, for example the cabin and interior fittings, vary depending on the brand and model. This concept allows Volkswagen to quickly meet market demand in a coordinated push-pull system without having to build up high inventories. Example 3, Design for Transportation Logistics. In this example, a product is designed in such a way that it is optimally suited for storage and transportation, designed from the outside, so to speak, to optimize logistical processes. In this example, the packaging was chosen to maximize the number of units that can be placed on a pallet. However, this requires that the product itself has been designed accordingly. Although such approaches are not always feasible, they should be considered and implemented if possible for products with a high logistics focus. And that's the end of this short video tutorial. Take a moment to reflect on your 3 key learnings from this tutorial. Consider how these learnings can support your daily work and how you can integrate them into your work routine. Take a short break now to reflect on what you have learned and to reward yourself before moving on to the next video tutorial. Please also note the disclaimer at the end of the video. Thank you for your attention.